Welcome back all. Okay, so in this chapter we will introduce standard types in C++ that are part of the standard library. So in short, STL. These types make your programming experience a lot easier and they save you a lot of headaches. So here we will cover the following ones. Let's put them down here. So std vector std string std map. Oh, okay. Okay, this is very interesting. This is a very interesting type map. It's very nice. I've actually utilized it in the keylogger course in order to save certain sets of pairs, which can be accessed through an identifier or an index, however you wish to refer to it. Anyway, std function and std dq. Okay, some of them you might have seen, some of them probably not, but we're gonna go over these and we'll see where we end up. So let me just go ahead and remove them from here. So the very first one that I'm going to go over is the vector. So std : vector represents basically arrays. Vector represents arrays that can change in size, so dynamic. It's flexible and it is also reliable. It is a part of the vector library as well. So to include vectors in your code, you would need the following. Basically just a lib here. Include vector. Yep, that's it. And then we can move on down. Not that much different from the arrays, but they do take a larger chunk of memory space. However, unlike the arrays, they are very much dynamic. Vector, let's go ahead and try one. So let's declare a vector of 10 integers. So definitely it's an int, and we shall name it vec1 or vets1. So vector, I don't know. Yeah, let's just leave it like that. Let's put this to 10. So all elements will initially have a value of 0. Do you notice the similarities with arrays? Okay, so let's go ahead and declare a double. So vector. I'm just trying to demonstrate the syntax here. It's not really that complicated at all. And it's fairly similar to the arrays, however you write it in a bit of a different fashion. And you can also declare an empty vector as well of 0 elements. Not that all the elements are initialized to zeros, but that all the elements are zeros. So the default initialization for the int type is 0, and for the double is 0.0. Down below we can have, like, I don't know, vector, and we can leave this one to be int as well, but you can just type in that's 3. That's it. You don't actually need to go any further. You can declare a vector that is completely empty that has 0 elements. Okay, so we can also declare a vector with elements, and we can state that we want to initialize we can state that we want each and every element to be initialized to a certain value without the loops, but it does need to be the same value in this case. Vector int, and then we can type in that's 4, and it's going to be like 3,7. Okay, it shall have 3 elements, and all 3 elements will be initialized to 7. Number 7. What else do we have? We can actually have, we can pool the size of the vector. So if you just type in, here, let me actually show it to you. Unsigned int, that's, I don't know, let's take the first one. Wow. Wow. I misspelled that terribly. So that's one size, and we can state that that is equal to VEC 1 dot size. So this will be the size of this integer. Well, the value that will be assigned to the variable vets1 size of type unsigned int will be 10, because that is the size of the vector. If we want to print out the elements of the vector, we would need to use a loop. Simple enough to do, really. So int I equals 0, semicolon I is less than, and you would be able to pull the size without any bigger problems by just using, I don't know, vets. Let's take the fourth one, and let's print out all the 7s. Dot size plus I std colon yeah, that's 4I. Okay, so these elements are accessed pretty much the same way as in the arrays. Do you remember this part from the arrays, how we managed to pull it? Although we couldn't use this, the for loops condition was somewhat different, but no big deal there. It will just go over each and every element, and it will print them out onto the screen. Here, let me just show you. So it's 777. That's what gets printed out onto the screen. Didn't go into the new line, just added spaces between them. Okay, so it is also recommended to access elements by using the dot at and then providing the index instead of going about things this way. So let me show you that as well. I mean, it's not just a different way of accessing it. So int el as an element equals vets1, and we put a dot and we type at. Same. Do you notice the same syntax as with the size? So size is some sort of a method that returns some sort of a value. At is pretty much the same thing. So we'll just say at and I don't know, 0. So the value of this would be the same as me basically typing in this. So that's 1 at 0. So these two will give you the same value. These two will contain the same value, so to say. Okay, so let's delete that. This is kind of intuitive. So at and then the element index, sorry, semicolon here. At certain index. Okay, it compiles and runs. Not really looking for the printout, just looking to see if I have any errors in the code. You can periodically do compile and run, build and run. Why? Just to see if you have any syntax errors. Don't write the whole code out and then attempt building it. Rather, instead, do many builds while you're actually coding. Okay, moving onwards, method.empty, method empty returns a bool value, which indicates whether the vector is empty or not. Let me go ahead and write that out for you. Bool emp. If you hear some birds in the background, there is nothing I can do about it. It's spring, so they're all around the building. Okay, so that's and it doesn't help that I feed pigeons here. So yeah, that might be a terrible thing for the sound, but oh well. Anyway, I don't think that you can actually hear them, but yeah, just wanted to mention that just in case. So vets2.empty. Okay, again, we're using the same syntax, just utilizing a different method to check whether the vector is empty or not. And we shall use another one, bool mp2. So empty1, empty2. That's 3.empty semicolon. So you see how we're using these methods just by a dot. Adding a dot here, and we're trying to figure it out. So vets2 is that empty, and you have vets3. Vets3 is empty basically, completely. It doesn't have any elements of whatsoever. While the vets2 actually has 5 elements. So this is a Boolean. It's basically true or false, one of the two. You don't need, this is not determining whether the variables have been initialized to something. This is just determining whether the size of the vector is equal to 0 or not. So you see the size of this vector is 0 and the size of this vector is 5. So this one is not empty and this one is empty. Simple as that. That is how it is evaluated. Okay, so now let's go ahead and take a look at pushback method. std : pushback method. How should we? Oh, let's do a cout. So vets3 dot size std : and L. Excellent. So this is going to print out the size of the vector 3 that we have here, which will be basically, I mean, okay, take a guess. What is the size of vector 3? This one is 10, this one is 5, this one is 0, complete 0. Okay, so if we do the following, let's dot push back 100. So this is adding 100. We'll see soon enough what I mean by that. And let's go ahead and do this. And this needs to be vets3. Okay, so let's go ahead and build and run this. It's 1. So you see, now it's no longer empty basically. So here it was 0. Where is it? Yep. So here it was 0, and we did a pushback, and then it's actually 1. Okay. What else can we do? We can initialize a vector. So that's like super simple to do. std : vector int let's go ahead and save vec5 and same as the array. So I don't know, 5, 4, 3, 2, 1. That's it. I don't really need any more. And you would print them out basically the same way you would print out an array. It's not a bad idea to use the for each loop here, as it is shorter than the for loop for this purpose and easier to use. So int I that's 5. Hopefully you know how to do this by now. std : cout I. Okay, so this is gonna create a very handy printout of all the elements here. And for example, delete the last element. So vets5 dot pop back. That's it. So just another method. This is how you would delete the last element. And let's go ahead and build it. Oh wait, vets5. Oh right. There we go. So 5, 4, 3, 2, 1, all printed out. So let's go ahead and just let's do this. So it's let's give it a endl. The : cout endl. Okay. There we go. So 5, 4, 3, 2, 1, and it's 5, 4, 3, 2. There we go. So it does indeed delete the last element. Okay, that would be it as far as the vectors are concerned here. Very, very, very similar to arrays. They function in a different way. They are more expensive to use in terms of system resources, but in a lot of situations they are worth it. They have a dynamic size, so it's not like the arrays where you need to have like one fixed size and that's it. It cannot change. It is one and it shall always have that size. And you might wonder yourself, well, why would we ever use arrays? Then why don't we always use vectors? Well, as I said, vectors are not as cheap in terms of system resources as the arrays, and sometimes you want to have certain things which are immutable. So wherever you can, use an array. Or if you cannot use an array, okay, fine, go to vectors. Anyway, bid you farewell, and we shall see each other in the next tutorial.